Let's discuss question number 52 and 53, which is link data question from test 3. This is from theory of machines, basically the epicyclic gear train part, or the gear trains part. In the figure, the input shaft, basically epicyclic gear train is given. So let's draw it first. So you have a basically you have a shaft A, which basically drives a gear, sun gear, and then you have a planet gear, and the planet gear, the shaft is free to move on something called carrier. Okay, and the carrier is a big one. All this carrier. Okay, now on the 3 you have inner gear, which is basically a ring gear, and this is just empty. Okay, so here you have teeth meshing, and here you have teeth meshing. This is ring gear which has internal teeth. This is planet, and this is sun gear. This is sun shaft A, and this is the shaft B. So A is connected to sun shaft connected to sun gear. B is the shaft connected to ring, and this is your carrier. Okay, and your planet shaft, which is free to move. So sun is represented by 1 here, planet is represented by 2, ring gear is represented by 3, and the number of teeth are given. This is T1 is 60, that is for the sun. So this is all the data that is given, and T2 is 15, which is your planet, and T3 is ring gear, which is 90. Okay, and what is given is that the speed, the input shaft A, the speed of A is 1800 rpm, and output, this is the input is given to A, output is taken from carrier C, basically the arm, and shaft B, or basically the ring gear, is stationary. Shaft B is stationary. Okay, so how do we solve these kind of problems? Now these kind of problems, the best thing is to solve by a table. So let's draw a table where what we do is we list out all the things here. Arm, which is nothing but the carrier C is the arm, then your sun, then your planet, and whatever is there. You have ring, and if you have any other epicyclic gear train, you have to just represent it. And now we just write down. So first we fix the arm, irrespective of the boundary conditions that are given in the problem. Forget everything. This table build up, the way you build a table is common, is same. So carrier arm, just fix it, give x revolutions or x revolutions per second to the sun. So the planet, now when arm is fixed, the carrier arm is fixed, okay, the planet can only just rotate about its own axis. So this is just like sun and planet, it's just like a two gears meshed together, but external meshing, but they can't, their axis can't change. So it's just like simple gear train. So when sun, so n1 by n2, I mean this relationship you should know is t2 by t1. Okay, this comes from your r2 by r1, and then modules being same, so you have the speed ratio inverse of the teeth ratio. So n planet would be n sun, that is x revolution of the sun, by ts by tp, where ts is number of t's on the sun by tp. Now we put minus here, to represent that if this is clockwise, then this minus will be anti-clockwise. Just to represent that clockwise and anti-clockwise, I have represented minus. Now ring. Now, so when arm is fixed, sun I give x revolutions per minute, planet moves with this much revolutions per minute but in anti-clockwise. Now ring and planet also we can consider in this same way. So in that same way, so speed, so it will be basically n2 is n1 t1 by t2. So now 1 is your planet, 2 is your ring. So you apply the same thing. So the speed will be n1 is nothing but the planet speed. So this is your planet speed into the planet teeth by the ring teeth. So this is how I get ring. Okay, and why minus again? Because now this is internal meshing, so when the planet rotates clockwise, the ring also will rotate clockwise. I mean, there will not be any change in the, so whatever the speed direction is there for the planet, the same speed direction will be there for the ring. Now I give y revolution, so it's like everything is, arm is locked initially, and it's basically the axis of each thing doesn't change, and it's just simple gear train. Now when I give y revolution, it's basically giving y revolution to all. I mean the now there is no teeth movement. I mean the teeth are locked, and when you move arm, everything moves by y revolution. So the total motion is, when you add these two, you get the total motion. So in general, whatever the motion is there is composed of these two things. Okay, you can analyze by fixing the arm and then giving y revolutions to the arm. So this is your total or the actual motion, the total motion. Okay, so now what is given is, now come to the problem. The shaft B is stationary, that means the speed ring is 0. So y minus x, TP gets cancelled, TS per T are 0. Okay, so y is equal to x. TS is my ring sun gear, which is 60, by ring is 90, so this is h2 by 3. That is one condition. Now speed A input shaft, which is this, is 1800. So x plus y is 1800 revolutions per minute clockwise. Okay, now these two are two equations, and the variables being x and y, so I just can eliminate. So I can just solve this and find x and y. So x plus y is 2x by 3 is 1800, and so x will be your 3 by 5, 1800. So this will be your 3 by 5, which is 5, which is 36, that is 1080 rpm is x, and y, when I substitute this entire thing here, I get y as 720 rpm clockwise, I mean the same directions of this 1800. So this is why. Now what is asked is arms, find the speed and the direction of carrier C. So carrier C is basically arm and the speed is y, so that is 720 clockwise. So that's what, so the answer is option is C for the first part. So understand this table method, you can solve any epicyclic gear train problem. So this is for the 52nd. Now let's try 53rd problem. So let's see now 53rd question, which is just the linked data question. Now what is given is relation between the torque applied to the carrier C and the shaft B. Okay, now before solving these torques, first understand that the total torque on the system, because each of the things is basically, I mean if you take entire thing as a system, the net torque on the system is 0. So torque applied to the shaft A plus torque applied to the carrier plus torque applied to the shaft B all should end up to 0, because the entire system doesn't angular accelerate it. Okay, everything moves with constant speed. Okay, and now the total power input has to be equal to power output. Basically from energy you get this. So this is first equation. Now power input, power output. Now this can be, now each power input point can be written as 2 pi nt by 60. Okay, so from this I can just write this equation as, so sum of the power input plus output, everything should add up to 0. Okay, so where are the power inputs point? Shaft A, so TA NA I'm writing, because even if you write 2 pi by 60, that goes to, that cancels also. Let's write 2 pi nt by 60 input power, then output is taken at the carrier, so 2 pi TB NB by 60. Then I don't have anything at B because the ring gear is fixed. Okay, so let's write everything where you have 3 points here: shaft A, shaft B and the carrier. So let's write the power related to thing. So this should add up to 0. I mean, the signs will take care. Okay, okay, now TB is 0 because, no, TB is not 0, but only thing is that B is fixed. So when B is fixed, NB is 0, ring gear. So so that if I substitute in this equation, I get TA NA plus TC NC is equal to 0. And what I want is A, and I want a relation between torque A, torque B and torque C. So I need to eliminate TA. So TA from this would be minus TC NC by NA. NC is your Y, NA was your X plus Y, and anyhow, I mean, it is asked in terms of NC NA, so we can write NC by NA, we can just write like that, no need to convert actually. So this is NC by NA, so this is TA. Now this, if I substitute in equation 1, I get TB plus TC, TA is minus TC NC by NA is equal to 0. So I need to find TC, so TC is 1 minus NC by NA is equal to minus TB, and so I want TC, that minus TB goes in the numerator, that becomes NC by NA minus 1. NC by NA is nothing but omega C by NA. I mean, instead of writing the ratio in revolutions per second, I can write the ratio in radians per second, it doesn't matter. Multiply 2 by n by 60 in the numerator. So this is what I get, TB omega C by omega n minus 1. So the answer for this is B. Option is B. The answer is TB by omega C. So just remember that when you have epicyclic here, the sum of all the torques has to be 0 and all the power should add up. This is from conservation of energy. Thank you.